Hello. um, yeah, so this is day 4 of my experiment. I had a bit of a gap because I went on holiday. Morning one, so outside you can hear the lovely garbage truck. I think it was a garbage truck. It's been there for a long time and it sort of made a lot of noise. It freaked out Blossom earlier. Hey, speaking of, Blossom's gone. Blossom's gone. She was like such cuddles this morning. She was like, love me. And I slept with like 2 cats in my bed last night. Which was nice, but it made sleeping kind of hard. Because I kind of half fell off the bed and I was like contorted in really weird ways. And I did wake up with a headache, which is bad, but I've sort of had a headache for the past 2 days, so I think it's like a long-term migraine sort of thing. But I took some aspirin, I seem to be like pushing through it, which is good. I gotta go to uni. I need to have a shower and go to uni in like 20 minutes. Ooh, I haven't done any of my assignment this morning because I've been having breakfast and doing this. Oh, well, I have been working on other uni work, so that's fair. I gotta finish that. I'm having comments for my judgment decision thing, which is all about using scientific method, which is really interesting. I mean, it's not about using scientific method, it's about correlations, and how we're actually really shitty at detecting them. So you need a correlation above like 0.7, which means that something needs to account for about 50% of the variance in the other thing for you to notice it. And all the psychological correlations are like around, I don't know, 0.3, which means it counts for about 15%, 10 to 15% of the variance. So, yeah, we don't notice a lot of things. Unless they're either really strong. But if we have a theory that we notice things, pretty much even if the real correlation is negative, we can see it as like a really strong positive correlation because of response bias. So that's something we have to deal with, which is really dodgy. I think personally, which is what I'm going to comment when I finish this video, is that our sort of like tendency to see correlations is probably an evolutionary sort of thing. Because if you think about it, you know, thunder, lightning, boom, crash, that's scary. They go together. If there's thunder, there's going to be lightning. And like, that's bad. Bad example. You know, okay, so if someone eats a berry and then a bit later they get sick, it's a new berry they haven't tried, odds are it probably is the berry. Even if it's not the berry, like, even if it's, you know, drinking water or something. That seems like the obvious new novel correlation. So you're not going to try that. So you're looking for, you know, like defensively looking for correlations. So you can just be sort of hyper aware of any potential threat in your environment. So it sort of like goes back into loss aversion, and it's just evolutionary. It makes evolutionary sense to see correlations in everything, because then, you know, if it is a useful correlation, it's fine. If it's not a useful correlation, there's probably nothing lost. In that sense, in the sense of people ignoring climate change data, that doesn't make sense. And that is really not evolutionary or adaptable, because we're all gonna die. Leaving you on that happy note, goodbye.